Good morning to all of you. I welcome to all in our lecture series on mechanics, that is your core paper 2, and we are discussing unit 4. The topic is oscillations, and this is our lecture number 16. In our last lecture, that is in your lecture number 15, we have been discussed about sharpness of resonance. In detail we have been discussed in our last class. So I suggest to all of you that before you have to watch this lecture number 16, at least you have to go the lecture number 15, that it will be better that you can understand today's video. So today we are going to be discuss about power dissipation and quality factor of forced oscillator. Okay, so as per the definition, a forced harmonic oscillator absorbs energy from the external deriving force which is dissipated in doing work against the resistive force and maintain the oscillation. So how power is going to be dissipated or going to be lost at the time of forced harmonic oscillation? Power is going to be lost when the oscillation is going to be happens against the resistive force, that due to from the air resistances or they are due to resistances at the hook where it is oscillates. So when the work is done against the resistance force or resistive forces, then power obviously is going to be lost or dissipate. So how much power is going to be dissipate, that we are going to be calculate. The instantaneous power P, here capital P, instantaneous power P, capital P. Why I am telling capital P? Because we have also going to be use the small p as the frequency, angular frequency of applied force. Okay, so power, here power is represented by capital P. So the instantaneous power absorbed by oscillator is P equal to F into V, because we know that any kind of work done will be represented by force into displacement, or we can say that the so called power is nothing but work done per time, like this. Okay, so work done in this way you can understand F work done will be F into displacement by time. So F into displacement by time will be V. So F into V will be represent the power. So the instantaneous power absorbed by the oscillator is F into V. So where it will be absorbed? It will be absorbed from the applied force. So here we have to consider F is nothing but the applied force in case of forced harmonic oscillator, that is F0 sin pt, and V will be nothing but dx by dt. Okay, but x equal to F0 by omega square minus p square plus 4b square p square into sin pt minus phi. This is instantaneous displacement at steady state. Already previously we got this one. I am going to show you. Wait, previously these things, this x we already got. See this one, F0. This is your equation number 15, you can say. This is your equation number 15. I can write here, you can write from equation number 15, you just write. Okay, from equation number 15. Okay, so V will be dx by dt. So first derivative of this one with respect to t, it will be, here you can see, it will be sin pt pi minus phi, that means p into cos pt minus phi. Let it is equation number 2, and this is your equation number 1. Now the equation number 1, we have to just put the values, f value and dx by dt value or v value over here. Then what we can get, f0 sin pt into f0 into p whole divided by root over of omega square minus p square whole square plus 4b square p square into cos pt minus phi. Okay. Now p, power dissipation, will be equal to, here you can see, we know that f0 by m will be f0. Here you can see that f0 by m is nothing but f0. These things we have been discussed at the initial time of your forced harmonic oscillator. You can check your note. Okay, f0, capital F0 by m is written as small f0. Here 0 is in the subscript. Okay, so now we have to put, if f0 will be written as m into f0, then it will be, the numerator will be m f0 square, here another f0 square into p, here p is the small p, okay, p, and sin pt cos pt minus phi whole divided by omega square minus p square whole square plus 4b square p square. P, this is p. Okay, that implies p will be equal to m f0 square into p into sin pt. This can be written as cos a minus b form, cos a into cos b plus sin a into sin b, that is cos pt into cos phi plus sin pt into sin phi whole divided by omega square minus p square whole square plus 4b square p square. Okay, now come to the next page. This will, the numerator will be m f0 square p, m f0 square into p. You just multiply sin pt with these two terms. Okay, then we can found this will be sin pt into cos phi plus sin square pt into sin phi whole divided by omega square minus p square whole square plus 4b square p square. Let it is equation number 3. Okay, so to obtain average power per complete cycle or period, we have integrated the equation number 3 from 0 to t. This is equation number 3. Okay, this is equation number 3, so you just write this will be the equation number 3. Integrate. Now to finding the average power, we have to integrate the equation number 3 from 0 to t. Here t is the time period. Okay, and divide with t, then we can find the average power. Now here see, this is the 1 by t, 0 to t, and this much, integration of this much. Same thing it has been written over here. Let it is equation number 4. We know that 1 by t 0 to t sin pt into cos pt dt can be written as 1 by 2t into 1 by 2t integration of 0 to t sin 2 pt into dt will be equal to 0, because we know that in a period 0 to t, either sin theta d theta or 0 to t cos theta d theta, over a period this value will be 0, the average value, because you just think like this, that suppose we have to consider the sin theta graph. This is your whole time period, right? For half time period this value is +1, or this is positive, this is negative. okay, or the maximum is plus 1, the minimum is minus 1. So the average will be plus 1 plus minus 1 by 2, that will be 0. So only for that this sine 2 pt, or it is in the form of sine theta dt in the whole period will be equal to 0. Similarly cos also will be 0. So no need to write these things whatever I am writing with pencil, because here I am explaining for you, so no need to write these things, okay, in your note. So what we found, this will be equal to 0, and 1 by t sine square pt dt will be 1 by 2, because this will be in the form of like this one, sine square pt will be written as 1 minus cos 2 pt by 2, like this. So here 1 by 2 will be come into the picture, so the answer will be 1 by 2. You can check it in your rough. So 1 by t 0 to t sine square pt dt value will be 1 by 2. Now the equation number 4 becomes what you can see. This is whole is the constant term can be moved to the outside of the integration. Here you can see, and this is cos phi constant, sin phi also constant. Here I told that sin pt cos pt dt can be written as in the form of sin 2 pt. So integration of 0 to t, this term will be equal to 0, okay, and integration of this one sin phi will be moved to the outside of the integration, and sin square pt dt will be 1 by 2, okay. So so here you can see that 1 by t, this term is cancelled out, this term, because this term will be 0 as per this one, okay. So here you can see integration of this one whole divided by t will be equal to sin phi into 1 by 2. You got my point? See, this will be the integration of, so this will be the integration of sin square pt into sin phi 0 to t, and here 1 by t is there, 1 by t. This value also can be written as 1 by t into sin phi, this is sin phi dt, sin phi can move to the outside of the integration 0 to t sin square pt into dt. So sin phi into this one 0 to t sin square pt dt by 1 by t will be equal to 1 by 2. So here it can be written as 1 by 2 sin phi only, okay. Now hence equation number 4 will be like this one, okay. So m f0 square p whole divided by omega square minus p square whole square plus 4 b square p square into half sin phi. Now this term is written as usual. See, m f0 square p whole divided by m omega square minus p square whole square plus 4 b square p square root over into 1 by 2. Sin phi can be written as this much, because previously we found sin phi is this much. I will be show you, just wait. Come to the beginning of our derivation, then you can find here. You can check your equation number 13. Sin phi will be 2BAP by F0, right? 2BAP by F0, sin phi value will be by F0. Now we have to just put the value of A. A will be nothing but this one, F0 by omega square minus p square whole square plus 4 b square p square root over. So here numerator will be f0, another denominator will be f0, will be got cancelled. We can found 2bp whole divided by 2bp whole divided by omega square minus p square whole square plus 4b square p square. Okay. Now see here denominator inside the root over, the denominators are same, so it can be written as the root over will be gone away. So what we can get? We can get that implies m is here m f0 square p square b, m f0 square p square b whole divided by omega square minus p square whole square plus 4 b square p square. Let it is equation number 5. But from equation number 2 we can found that maximum velocity of oscillator will be this much. Now you just go to the equation number 2. From equation number 2 see here in equation number 2 the V will be maximum when cos value will be maximum means 1. If cos pt minus phi will be 1, then V will be this much, which will be the maximum value. So but from equation number 2 we can found that the maximum velocity of the oscillator will be this much. Let it is your V0 equal to f0p. See this will be the your f0p divided by omega square minus p square whole square 4 b square p square root over will be this much. So p average can be written as C V0 f0p by root over of this one. So here f0 square p square by this much can be written as V0 square. So P average will be M into V0 square into B. Let it is equation number 6. This is the power dissipation per cycle for forced oscillator. Now another term we can derive in other way. At resonance condition, what will be the average power dissipation? From equation number 5 you can see, from equation number 5 it can be found that for omega equal to p, if omega equal to p, then p average will be the again maximum here, because if p equal to omega, this term will be 0, so p average will be the maximum value that we are going to be get. So here omega equal to p, when we are going to consider omega equal to p, that is nothing but is our resonance condition. Already we have been studied in our last class. Here you can see at p equal to omega, this is nothing but is our resonance condition. So at p equal to omega, that means at resonance condition we can found p average will be maximum. So this is your general form of average power dissipation. This is one form. This can be written in another form, but at a resonance condition it will be the maximum. The value will be, if this will be the 0, then p average maximum will be m f0 square b p square, m f0 square b p square whole divided by 4b square p square. 4b square p square is equal to m f0 square by 4b, and p average maximum will be b. Here b can be written as so here I done one thing, that here I multiplied one m with the numerator and divided one another m, so it will be m square f0 square divided by, this can be written as 2 into 2bm. Here m is that is one multiplied and another is divided. So m square f0 square divided by 2 into 2bm. Okay, so m square f0 square is there, 2 into 2bm is nothing but gamma. We know it from our initial discussion. You just go through to the initial derivation, you can found 2bm is nothing but gamma. Gamma is your called damping coefficient. Gamma is constant called damping coefficient. Okay, so this is another form of not another form, this is the power dissipation, maximum power dissipation at resonance condition. Okay, this equation number 5 and 6 represents the average power dissipation in the different form. You can remember in this way or you can remember in this way, and at resonance condition we found that the maximum or the power dissipation is maximum. Okay, and you have to always remember one thing, that at the resonance condition, this is most important, it is required in your next 5th semester and 4th semester also. Power dissipation will be maximum at the resonance condition. Okay, at resonance condition also we found amplitude is maximum, and power dissipation also maximum. I can show you a simple example. See, this is a one rover. So if I am going to stretch, again it will be restore, stretch, restore. You just imagine that I stretched this rubber up to this much distance. How much I given the force, exactly that much amount of restoring force is induced, which will act a reverse direction with the applied force, right? So inside this rubber, restoring force acts to restore the rubber. Okay, you just imagine this much distance stretching, how much restoring force will be induced inside the rubber. If I will stretch much more distance, then restoring force will be maximum. If I will be stretch another distance, the restoring force will be again increase. So you just imagine, for this stretching, the force or the so called restoring force will be increased. That means the work done will be increased. If the work done will be increased, that means the so called your power will be also increased with that proportionate. That means in either way you can also understand. You just think, I stretched this rubber up to this much for a long time period, for suppose for 10 hours. What will be the strength of this rubber? You just imagine. And in the second case, I stretched this rubber up to this much, up to 10 hours. In which way the life or the life of the rubber is going to be sustained? For less stretching. For long stretching, the life of the rubber is going to be reduced, because due to the high power loss. So at the case of resonance, the amplitude is maximum and the power loss also maximum. Like that, the concept that you have to be remember. Now we have to go for the next section, that is your quality factor of forced oscillator. So as per the definition, the quality factor Q of a oscillator is given by 2 pi average energy stored whole divided by energy dissipated per cycle. Okay, this is the average energy dissipated, and the per cycle means into T, and average energy stored. So we know that the total energy is nothing but kinetic energy plus potential energy. The same expression or the same you can say the formula we have been used for damped harmonic oscillation, that quality factor is equal to 2 pi into average energy stored whole divided by energy dissipated per cycle. Total energy will be kinetic energy plus potential energy, that is half mv square plus half kx square, half m. The v will be nothing but this one, pa cos pt minus phi, because we have to consider the steady state displacement and corresponding velocity. Okay, because in case of steady state we can consider the so called quality factor for the continuous oscillation. So here x is equal to a sin pt minus phi, dx by dt, or the velocity will be p into a sin a cos pt minus phi. Okay, p into a cos pt minus phi, the first derivative of this one, it is written this one, pa into cos pt minus phi whole square plus half kx square, half k will be written as m omega square. We know that k will be nothing but m omega square, and x is nothing but your sin a sin pt, a sin pt minus phi whole square. So here k will be nothing but k by m equal to omega square, or k equal to m omega square can be written over there. So this will be half m p square a square cos square pt minus phi, and this will be half m omega square a square sin square pt minus phi. We know that average value of cos square pt minus phi and sin square pt minus phi over a complete cycle or time period t is 1 by 2. Here just we have been discussed this one. Okay, so then this value, or if we are going to integrate 0 to t whole divided by t of cos square pt minus phi, the value will be half. So half into half, 1 by 4 m p square a square, this will be also like this, 1 by 4 m omega square a square. Okay, and the p average what we found from equation number 5, here from equation number 5 means this one, this one, that is f m f0 square b p square by omega square minus p square whole square plus 4b square p square. See here f0 square whole divided by this one can be written as a square. You just check your note, we got the amplitude value will be this much. This is your f0 by omega square p square whole square plus 4b square p square root over. If we are going to consider a square, then it will be f0 square by whole square, then if you are going to consider whole square of the denominator, then root over will be gone away, will be this one. So this p average also can be written as m, this will be a square b p square. So same thing I have been written here, that your m b p square a square. Okay. Then at the time of damped harmonic oscillation, relaxation time and b relation related with b equal to 2 by tau. See, tau equal to 2 by b, or 1 by 2b, or b equal to 1 by 2 tau, 1 by 2 tau. So m p square a square b can be written as 1 by 2 tau, 1 by 2 tau. So we have to put these two values, this one p average and e average, in the equation number 1. What we can get now, the equation number 1 will be 2 pi into 1 by 4 m. See this one, e average is this one. Okay, 1 by 4 m p square a square plus 1 by 4 m omega square a square whole divided by m a square p square m a square p square by 2 tau into t will be nothing but 2 pi by p, because here we are considering the applied force frequency. Applied force frequency means 2 pi by p, not omega. Here p is small p. Okay, applied force frequency, that is your p, so it will be 2 pi by p. So further simplification, we can get a square a square got cancel, and 2 pi got cancel. Here 2 1 2 is got cancel. We can find 1 by 2 p square plus omega square, p square plus omega square. This tau will be moved to the numerator, tau by this p will be half p square plus omega square. Here you just multiply one p over here and divide p, it will be p square, this will be p tau. Okay, this see, this is the different form after simplification, so you can remember this one also for your exam purpose, no issue. Okay, so here q equal to 1 by 2, here p is going to be this p square is going to be divided with this and this, it will be 1 plus omega square by p square into p tau. Let it is equation number 2. But at resonance condition, that is p equal to omega, we can found this omega square by p square will be equal to 1. So 1 plus 1 equal to 2. So 1 by 2 into 2 into p into tau will be equal to p tau, p into tau. At the resonance condition, p small p equal to omega, so also can be written as omega into tau. This is our quality factor of forced harmonic oscillation. So this is all about your forced harmonic oscillation. So in today our forced harmonic oscillation has been completed. In next class we are going to study some new topic. So I suggest to all of you that you go through this video and previous part of this forced harmonic oscillation. Okay, so I am just going to be show you what are the things we have been discussed in case of forced harmonic oscillation. See, here we started the forced harmonic oscillation, we derived its general equation, then complementary function, particular solution, complementary solution, how much we have been found, what is the steady state we have been discussed in detail, and with the derivation we found amplitude of forced harmonic oscillation will be this much. Then we found the complete solution is in the form of this one. Then we discussed the resonance condition where amplitude will be maximum, we derived in detail. Then we discussed about the sharpness of resonance. Then today class we have been discussed about your power dissipation and quality factors. So we go through these videos, today video and last videos regarding forced harmonic oscillation, and write down the note perfectly. If you face any doubt or any problem, you can contact with me and we are going to be discuss. Thank you so much for watching this video. Thank you.